Good morning. Cheers, everybody. Lukewarm coffee. Wicked. How's everyone doing? Hope you're all well. Namaste. Tishipu. Yeah. It's stream day. Yay. Haven't shaved. Yay. Messy schematic day. Yay. Oh boy. USB everything. Wow. Just wait and see this. Out of control. Out of control feature creep. It's going to be awesome. It's going to be so good. How is everyone? I missed last week. Sorry. I'm still unwell. Even yesterday I was trying to decide if I'm going to stream. I have this lingering thing that won't go away, and it'd be like I might feel better for a couple of days, and then it's coming like up and down in waves. Tested for COVID, tested for all the different flus and all that stuff, and there's nothing. But I seem very giddy today. I am no. I'm excited to be streaming. I mean, this sounds crazy. It's like I hate it when I don't stream. I feel like I'm letting everyone down. I feel like I'm letting myself down. But I'm excited for what I'm working on at the moment. But it's out of control, as you'll see. Anyway, the others tells me I should go to the doctor, try to work out what's going on. Hello, Julian. Well, going into winter, it's never good. Yeah, it's I don't know if it's a winter thing. There's a lot of flu-y, virusy stuff going around. Like a lot of people are sick. Like it's that time of the year. But like we passed it around in my house for a little while at the start. But I think this is week 5, and I've still got sinus and headache and watery eyes and stuff like that. It's just can't seem to shake it. Control is overrated. Well, yeah. Wait, what are we talking about? Control of what? I need clarification, Shipu. Boy. I'm not even going to preamble. There's not really a lot to talk about in terms of update. Been busy manufacturing, finding it hard to find parts at the moment. Finally got an allocation of ESP32 S3, the FN8 version that I use in my tiny S3 and my nano S3s. Although they haven't shipped yet, only got confirmation yesterday that I'm up in the queue now. It was like a 7-week wait. There's hard finding parts at the moment, and parts that really have nothing to do with the silicon, with the memory shortage, are starting to affect me. So, like, flash, which, gone up 3 times in price for stock that it's not new stock, right? People are price gouging. It's just, anyway, it's out of control. So yeah, I've been finding it really hard to. Yeah, I was sometime. In this case, the FN8s were there was a 12-week wait. They managed to skip me ahead 5 weeks to 7 weeks, and I managed to grab some at a more than double, like 2.5 times the price, to tide me over for a bit, which kind of sucks because then I'm making boards and shipping them and I'm making nothing on them. But I just had orders to fill and I couldn't wait. And usually with my contacts at Espressive, they say to me, oh, there's going to be like a 6-week wait on something. And I'll say, please, 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 I just need one reel. And they normally get back to me within, 4 or 5 days and say, okay, we can get you a reel. But this time, no, it was the 7 weeks, and it was infuriating. It's like it's watching grass grow, right? It just, it was frustrating. Hey, Super Bruce, who's a beard stranger? Yeah, no one in my family wants me to grow a beard. I've never liked. I'm just at that itchy stage, right? I don't think I look good with a beard at all. This just looks like a scruffy unshaven at the moment. I've tried growing a beard a couple of times. I don't know. I don't particularly want a beard, but I just have not had the energy or the inkling to shave. So it is what it is. But it's like if you see me touching my face today a lot, it's at that point where it's starting to get itchy and not happy. Not happy. Anyway, I'll be fine. So what have I been doing? I mean, I've been checking a lot of client work still. I tried reducing my load on my client work, and that has not happened, which has been interesting. I did get to work. I can't show you this, although I don't think there's anything. Okay, there's nothing on this that reveals anything, so that's good. I can't really tell you much about it. This is a prototype 1. This is prototype 2 on the way. I'll explain the difference in a moment. I'm not going to go into a lot about what it is. It's like kind of like green label. Let's see if I can focus it. It's just a microcontroller board, ESP32S3 for a particular client. But what's interesting on this board, this is the first time I've worked with a battery that is a 3-wire with a thermistor. So this is a custom battery. I'm not going to show that. It's a custom battery for a client. It's just it presents as a single cell, but with a thermistor. So I had to come up with that. And the whole point of this is it's going to be wirelessly charged. The battery's going to be wirelessly charged. I'm not doing the wireless charging circuit stuff. I was asked to, but I said no. This is for a company in Europe, and I can't really design their wireless charging thing because it's got to go into a specific docking station. It's for an automated process, fully automated, like dark room process, and I wasn't able to get all the specs I needed and couldn't get anything from them, like in terms of distance to the coil and all sorts of stuff, and so they're handling that. But so there's obviously USB power for flashing it, serial monitor, whatever, and then this what I'm holding here, this cable here. Ignore the colors, is that's the 5 volts coming in from the wireless charging. So there's 2 5-volt pins and 2 ground, two 5-volt wires, 2 ground wires. And so had to source a new charging IC that can do that allowed to set all the different parameters for the thermal thing, because it's a fully automated thing, unattended. They need to have like extra fault tolerance and the ability to check the battery and make sure that it's not just a overcurrent, undercurrent, but they can check the temperature of the battery and shut everything down at the right time and whatever else. So that was an interesting challenge. Because it was a custom battery, I couldn't just take any battery and try it. I had to wait for them to get the batteries made and ship me a battery. So the redesign was just adding a heap more thermal. So it's 4,800 milliamp hours. milliamp, 4,800. They say, I don't know, pretty heavy, like it's really heavy battery, and so it takes forever to charge. So when I got it and I put this on the circuit and I had it set to, they told me they wanted 550 milliamp charge rate, which I thought was too low, but that's what they said they wanted. And I put it on and I was charging it on my bench supply, watching it, and it was sitting at 565 milliamp. And when the battery arrived, it was sitting at 3.4 volts, right? And it took almost a day and a half to get it to 4.3 volts. Fire suppression, well, that's something they have to deal with. I mean, this is a massive installation. Like, this is not a simple thing. And I had already designed a product for them that they've been using live for the last couple of years in their facilities, but that was in a attended manufacturing space. This is one of their brand new facilities that is completely unattended. I don't know what they're doing for fire suppression. I don't know what they're doing for all the other stuff. That's not my problem. I'm not writing any firmware. They just gave me the specs, and I said okay. So anyway, so I kept upping the charge rate. I got it to about 800. This IC can go up to like 1 amp, right? And like really 1 amp. A lot of them, especially the Chinese stuff that you look at online, they'll say it goes up to 1 amp charging, but you can't really get it above 600 milliamp, or it'll just combust the chip, right? This thing does, but I did not add near enough thermal support for it at the high rate. So I've added stacks more, including a massive open, like no solder mask, so open copper at the back, and enough space that we can stick a heatsink if we need, because they need to be able to charge it faster than that. Ideally, they want to be able to recharge the battery. They don't know how depleted the battery is going to get, but they want to be able to, go from 3.3 volts to 4.2 volts in 6 hours. I don't know how they're going to do it and get a smaller battery. So I've been playing with stuff like that, and other client stuff. What I'm going to work on today is, it's client related. It's not a client board. It's a test board for a chip that I want the client to move to. So yeah, but it's getting complicated. But I'm just going to say hi to everyone in the chat first, actually, and then I'll jump into the schematic, which, yeah. Just Maker, hello. Graham, good morning. Richard, hello, Richard. Intimate Tech, hello. Beata, Dishipu, namaste. Julian, hope you're well, Julian. David Dessa, hello. Super Bruce, Sid, hello. Mine gets itchy at 1/4. 1/4 inch. What's an inch? How long's an inch? I'm kidding, but really, it's a digital world. We're in millimeters. Come on, metric, all the way. Wagon Loads, hello. I went through the itchy stage about 50 years ago, so I stopped shaving. No problem since. I think I look terrible with a beard, but I'll see how far I can go. Xmicron, hi. Rayburn, hello. Did I miss anyone? No. I can't. I've lost all my stats. My YouTube stats are gone. What's going on? There we go. 36 concurrent. Oh, I don't know where everyone is. If I miss anyone, I'm sorry. Okay, schematic time. Let's just get into it, and I'll explain what this is. This is an unfinished schematic. I'm in the middle of... Okay, let's just start off with... So after Wait, what I should show you first is... Oh, I should show you this first. Hold on. I'll show you an update on a different project, which is shipped back to me. It's already been made at JLC PCB, and it's on the way back. But you never got to see the finished version I want to show you that first, which led me into this chip. Open. Chips with more than 16 pins scare me. Yeah, this one's got a few. Does have a few. So I finished off that controller board that I was designing on the stream the other week. The Ethernet PoE board, PoE Plus board, ESP32 S3. I settled on the 5-pin FPC connectors. And so this is the board I ended up designing, which hopefully will work. There's a few things on there that I think are kind of pointless, maybe, but I populated everything anyway. Like I left the MEMS microphone, I left the audio amplifier, speaker output, I left the BME 380 temperature sensor. The input GUI, yeah, it's working again. I actually wrote my own Python script to do it when theirs wasn't working. So I got the option for both now. Hey, Technubulus, hello. Had to get a throwaway Android phones. Only a week later, some interesting thing from Ali arrived. Wait, what? You got an Android burner phone? Anyway, so it came out okay. I ended up having to mostly make my own or fix up their model for the PoE module. But I think, I'm hoping this will work, right? And it probably will set fire to not just my soul, but my my whole factory. So once I've assembled this and I see if it's working or not, I can then show you the other half of this that this is driving, which is pretty cool, but it's kind of pointless without this. But so this had that that new Ethernet chip that I can't remember who it was. Who was it? Mike put me onto the CH390D. I was looking at using the WIZnet chip, and so after getting all that in there, I started looking at all of their other chips just to see what is that the same PoE plugged into an Arduino. Wait, PoE and Arduino have nothing to do with each other. Wagon loads. PoE is just power over Ethernet. So when you say that PoE that plugs into Arduino, every I don't know which board or how they've implemented PoE or whatever else. This is for PoE Plus. So I'm using an off-the-shelf module to do the power management for it. Because I need 25, 30 watts. But there's hundreds of PoE adapters, so adapter is different. This is not an adapter to connect to something else. This is a complete board with PoE. There are lots of PoE adapters for microcontrollers and stuff. I don't know anything about Arduino's one or Arduino's whatever. This is not an add-on board for anything. This is a complete thing. But I do want to make, once this works, I want to make an Ethernet add-on, an Ethernet shield for my boards, but it won't have PoE. Or if it'll have PoE, it'll be an external module that you'd have to plug in or something. Hey, Amory, how you doing? So anyway, I started looking through the rest of their chips. And so, okay, enough with this. Put that away. Well, PoE is standard. PoE has nothing to do with Arduino or microcontrollers. It's part of the Ethernet consortium. So PoE is a standard, but there are many types of PoE. There's PoE, PoE Plus, PoE Plus. They've all got different, designated version numbers, like 802 dot whatever, AEX, A blah, blah, whatever, right? Nothing to do with Arduino, nothing to do with a microcontroller. So just to be clear, yeah, two totally different things. Whether there's an adapter for an Arduino or not, PoE is just power over an Ethernet connector. right? Hey, Terran Walker. Terran Visitor. Sorry, Visitor to Earth. J. Yes, this PoE set fire to the world. Anyway, lots of different standards, and then there's also a pre all of those, which is like a DIY PoE, which is a lower voltage stuff, which is not compatible. And if you plug something into something wrong, boom, fire. So yeah, it's a yeah. Okay. So it led me to their USB hub chips. So one of the hang on, some Arduinos have about 7 unpopulated pins. Don't know. As I said, I know nothing about any of the adapters or anything for Arduinos, whatever. I don't know. Except I decided to use some different voltage over the PoE wires, not standard. Ubiquity being one. Sure. You've called ground pin 69. The data sheet says pin 0. You looked at the data sheet already? So there is no pin 0 on here. What they're meaning is the EP. So this symbol, I didn't make the symbol. This symbol's directly from LCSC/Easy EDA. So I bought the chip through LCSC, and I pulled their symbol and footprint. I've already modified their footprint because it was terrible. But yeah, anyway, the data sheet says pin 0. There's no actual pin 0. It's that what they mean is the big EP pad at the bottom. Don't knock Ubiquity. They're really good stuff they make. Anyway, so I've already got a thing for a client that has it's a specialized USB hub for their products, right? And it comes in a 12-port variant and a 4-port variant, right? That's all I'm going to say. And it's using an older TI USB hub chip, which works fine, but it's only USB 1.1. We have some future products we're going to be designing that. So USB 1.1 is perfectly fine for all the devices we're doing. You can plug an ESP32S3 into it and get full bandwidth because that can only do USB 1.1 full speed. Hey, Sean. Yeah, right. It's crazy. All that PoE is out of control. Definitely out of control. Anyway, so I wanted to look at moving it to USB like 2.0 high speed, which can do obviously way more bandwidth, 480 megabit, and because we're going to have a need for that soon. And so I was looking at different chips, and then I remembered the C8 stuff. And so the C8 chip comes in 2 variants. I've actually got it. Data sheet open. So it's a CH339, and it comes in a 4-port and a 7-port. 4 and 7 downstream ports. It's always plus the upstream, right? So the 4-port chip, which is the 339F, has 1 upstream and 4 downstream, and then the W chip, which is the one I'm working on, has 1 upstream and 7 downstream, which is the same as our older chip that we're using, 1 up and 7 down. But this chip can do USB 2.0, right? High speed, so 480. They've also got, though, a whole range of really goodies. Did I leave their website open? I thought I did. Here we go. If you've never looked at their website, well, this is the 339 data sheet. Actually, I'll go back to the product page. This is the product page for the chip I'm using. They they make some. I mean, they make a lot of RISC MCU stuff. Like BitLooney uses a lot of their chips and stuff. I'm not really interested in the MCU stuff, but they make some really awesome peripheral stuff, right? And so if you look at their the USB hub lineup, they go all the way to USB 3 stuff, which is just, I'm not interested in trying to route a 12-port USB 3 board. Not yet. I first want to get through routing a 7 or a 12-port, so 2 chips of USB 2, which has got a much stricter routing requirement than 1.1. 1.1 can pretty much do whatever you want, right? They're supposed to be impedance match differential pairs, but at the end of the day, they don't have to be length matched. They don't have to be impedance matched unless your traces are half a meter long. It's really forgiving. 1.1 is very forgiving. 2.0 is not forgiving. 3.0 is out of control. So but they do have USB 3, 5 gigabit, right? I mean, that's just nuts. But they don't. I thought they had a 7-port USB 3, and they don't. But that's okay. I could always use 3 4-ports. Matters for use case, but a lot of commercial hubs show up as 2x 4-port chained, 3 on the first level, with the 4th being used for the other ports to make 7 on the. They're probably just chaining 2 4-port chips rather than a 7 or whatever. I don't know. But the nice thing about the chip that I'm using is it's not a drop-in replacement or anything else, but functionality-wise it is. It's got a lot of features that I'm not using on this particular chip. It's got some amazing features. So, for instance, it has... So these guys do a lot of peripheral chips, right? So this has a USB to Ethernet bridge built in, and a USB to UART, and USB to JTAG, and USB to SPI, and USB to I2C bridges. It's got all those bridges built into this chip. So like I could, for instance, connect an RJ45 connector to this and have a USB to Ethernet bridge. And on the host, it would appear as a USB device talking via Ethernet, right? Without me having to add anything else. Has it all. Built-in functionality in the chip. Hardware does it all. I'm actually looking for a 10-port USB powered hub. We'll get onto that in a second, Julian. I've got lots of USB hub ports like around, but I need a powered. I need individually powered ports with upstream 10-port. Anyway, for a different project. So this has a whole lot of stuff, which is just amazing. Like you can, I could connect the TX and RX pins of an ESP32 to this chip directly to the USB UART bridge. It's like a CP2104 type thing, right? And it would present the ESP32 as a serial port without taking up one of the USBs. Or I could connect a screen, like an SPI screen or SPI flash, to the pins on this, and it would present as a flash storage via USB. So it's got a whole lot of stuff, but I don't need any of that. All I want is a 7-port hub that just works without any configuration, and that's what this chip does. Yeah, it's got heaps of stuff. And no, it doesn't have CAN bus. They have other chips that have that, but they don't have a CAN bus bridge on this one. Oh, hang on, SM bus. Wait. On this one? Oh, and it's also got, all of their ones have SD card socket. So you can put an SD card socket on there and it would automatically appear as a storage device via the chip, via USB, right? Amazing stuff. I don't need any of that. So as you'll see here, I've got all of those pins are just disconnected, right? So these are the SPI disconnected, the SD card stuff disconnected. Anyway, all I'm using, this is the Ethernet, the two pairs. All I'm doing is using the upstream, so USB in, and the downstream. That's it. And yeah. And it doesn't even need an external crystal. I'm going to put it there anyway, just in case. But I only need the crystal if I've got the Ethernet connected. If I'm not connecting the Ethernet, it's got an internal crystal. Would it work as a wireless HUD? Wireless, nothing to wireless. It's not wireless. It's USB. It's a USB hub. It requires USB connection. So yeah, only one of the 7 downstream ports is USB 3. Oh, the one that you bought? Yeah, you got to be careful. So one of my clients was looking at charging banks. They needed 10 charging ports for iPhones, right? To plug 10 iPhones in, or through MagSafe, whatever, for a thing they're designing. And they spent like weeks and weeks trying to find, because what you get is, like, they say, oh, here's a hub, a charging port hub. So it's not data, it's just for charging, USB-C charging. And they say, oh, it's rated for this thing, and it's, you can put this many amps through each port. But when you actually look at the specs, you can put that many amps through each port, but only if you're using these ports, or only if you've got less than 4 ports connected, right? It's once you've got them all connected and all 10, suddenly you don't have any of that stuff. You got to be really careful when you're looking at the specs for all these products these days. They cheat you out of stuff all the time. Does it have enough throughput for a hard drive if connected? That's not what this chip is for. You're misunderstanding. This chip is for a host to see the connected devices on the chip. A host meaning a computer. It's not for a hard drive. It's not for an ESP. This doesn't connect. I can connect an ESP32 to this and see the ESP32. This is just, it's a USB hub. Wagon Loads, it's a USB hub. Read the data sheet. Did I put the link? Did I post before the link? I did. Read the spec, right? It tells you all about it. Okay, anyway, so this thing started off with just I'm going to stick a chip down, right? And I was going to have, just starting with one chip, like obviously I'd need 2 for 12 ports, but I was just going to start with one chip, 7 USB connectors going to it. Oh, the other thing is I'm not powering, you can power each port through this chip. So you have one 5 volt, whatever many amps coming in, and then all the power happens individually. And you got individual power control. Here you can see power enable on each one, and then you can do, you got overcurrent for checking them as well, right? But I'm not doing that. I'm using what's called gang mode power, or I'm not even doing that real effectively. I'm setting overcurrent always to 3 volts, which means I don't care about overcurrent, and I'm not using, so overcurrent 1, all the rest get ignored, and power enable is disabled because I'm powering the 5 volts separately. So the client product has separate power coming in, and each port is power enabled, controlled. It can be turned on and off individually, and the power comes from a different source, not through the hub chip. So that's what I'm simulating, because this is an experiment for them. But that was what I was originally going to do, was just stick 7 USB ports on there, and with just power coming in to try it out. But then I thought, well, hang on, I might as well keep pushing this and getting it closer to what the replacement, like what the spec is for the thing, right? Sorry, so what StarTech used to be? Don't know who StarTech is. Sorry. And so I've started, like, here's my USB. I had different USBs, right? But then, you know what? I need to be able to turn the power on and off. So I started redoing it, putting a load switch in. That's not how the client product works, but it's too much to do. I don't want to take their thing and convert it. I want to just try this chip, but it's become out of control, right? I want to be able to individually turn it on and off each port. And the other thing was, I thought, why don't I just add an ESP32 onto the board, and that can do things like I can have USB sense coming in, so I can sense if a device is connected or not, right? If it's been connected, and then whatever, and then that turned into I might as well put an IO expander on here as well, and that I haven't finished fleshing this out yet, so that way I can turn on and off the power. There's not enough IO on the ESP32, right? But that way I can turn on and off each port if I want to, and I can also check the fault tolerance of each port if there's a problem for the overcurrent or protection stuff on the load switches. And so then I thought, I better add the load switches. So I started working on that, and now I need to replicate this into every single one of these. Now, on the client thing, there is no USB-C port. It's a connector that devices plug into, which is fine. But in this case, I don't have that. I can't do that. So I'm just going to do USB ports. So I've got an upstream USB-C coming in, right? So that'll be connected to my Mac or a Raspberry Pi or a Windows PC, which also drives the 3.3 volt regulator, which will be powering the hub switch and the ESP32. And then I've got a separate source, which I'm just going to use USB-C for the moment, or I might actually move that to be just a screw terminal. I don't know. But for now, that could be a Raspberry Pi 5 amp power supply, right? It doesn't matter for now. I just need 5 volts coming in with, amps. So that'll be the main power supply just for power. You see, there's no data in and out here, right? So, this USB-C is the upstream. The ESP32 S3 is connected to USB 1 of the hub. So I need 12 ports. It's 7 downstream on each. That leaves me free 1 on each, right? So that means I can connect the S3 directly to one of them, and the S3 will appear as a USB device, right? So I can flash it, I can communicate with it, and can get it to control stuff. Do you want amps with your volts? What? So on the client product, it's a 19, 20 volt supply coming in. No, or 20 volts, 6 amps, whatever it is, which obviously when that gets dropped down, and then each port has its own buck, right? So, but I don't want to do that. I mean, that's a lot of electronics to stick on this, which I don't need, right? So, yeah, this will be fine. Wait, why isn't the talking going? You're messing up with comments again. Ping pong? What? Isn't that a bit much low ESR capacitance on the USB port? Isn't this, you're talking about this here? This is a requirement for downstream USB. No, but why didn't the say work? Oh, I know why. Hang on. Hold on one moment. I think I've Let me just fix this. I think I switched my Python.
Unexpected Maker says hello.
Okay, talking's working again.
Intermit Tech says ping pong hello.
Yep, okay, it's working now. So part of the USB 2 spec is that the port, not the hub port, not per USB port, has to have 120 microfarad of capacitance for inrush current, whatever else, for hot swapping devices. And I don't have a 120 microfarad cap of any type here, and I don't want to stick any type of big electrolytic cap or something on there, so I can do it just by sticking a bunch of these. Oh, and the cap has to be a very low ESR. So by putting 5 of these in parallel here, basically that's giving me, 110-ish microfarad. And the more I put in parallel, the lower the ESR becomes. So, yeah. So this is just apparently it's a USB requirement. So, okay. So I can't turn the power on and off individually unless I stick some type of switch there. And I just happen to have a whole bunch of these TPS 2552s, which I use them for as a they're a load switch, but it's also they also do current limiting to 1.5 amps and allowed to put more than a 10 UF on a USB connector. Right, this is not the connector, this is the power for the port. But interestingly, I'm not using, so for the hub port switch, but I'm not using the hub for power, but I'm still putting that on there externally because that's what they recommend. Yeah. So, so basically I need to go through and do all of these. I tried working out how design blocks work in KiCad for schematics and stuff, and couldn't work it out. Oh my God. So I'm just having to do all these individually, which I know is just crazy, but that's what you all come here for, right? To watch me do crazy. So this is going to end up being a ESP32 controlled 6-port hub, USB 2 hub, that technically I can stick a web interface on, so you can turn on and off individual ports and monitor ports, and it'll be a USB hub. So you've got 5 MLCs per downstream port. No. It's for the power coming in. So it's only on it's only on the main supply coming in that is feeding it. So there's no PCB right now, right? I'm still at the schematic stage. I've not even imported anything yet, right? So it's a bit hard. Maybe it's hard to visualize at the moment, but this is the power input, right? And then that is fed into each load switch. And then the switch will power the port. So it's one bulk of power before each of the switches to the USB. Sure, for Bank of Blackmagic converters. Okay. Yeah, well, I mean, I could imagine this might be a useful thing. I don't know. Need to make sure I do all this correctly. Okay. So it's USB-C, USB 3, power enable, USB 3. Okay. So no, just do 4. So I'm using USB 1 for the ESP32. I know it probably would have made more sense kind of to have USB 1 to 6 be the ports and 7 be the ESP32, but I'm doing it this way on purpose because I want this will match what the intended client stuff is, which will allow me to transition this over if it works. Four. It doesn't matter what we found in Australia. We're not allowed to mine them. Our government are absolute sock puppets. Let's not go into politics, because seriously, I will lose my Scheisenhausen. So because I'm not using the chip for all of this, I could use the chip, and what I could do, the chip has, it's a modern chip as opposed to the other one we're using, right? So this chip has, see here, power CC1, power CC2, and it also has a hub CC. So I could preset on here, I could put the 5.1Ks on here, on these two pins, and not have to put them on here, on each individual one, but only if I was doing the power through the port. The reason I can't do power through the port is I need to be able to deliver 1.5 amps per port. Not for this case, right? But the client board delivers 1.5, or actually up to 2 amps per port to the devices being connected, so they can do rapid charging. And I can't push that type of current through this chip. Like, there can be 12 connected devices in this thing at once, all charging batteries at an amp plus the overhead of the devices. Can it do external PD control? No, but they do have USB PD chips. You wouldn't do PD control through this specifically. I mean, sorry, whatever you set these resistors to will do, that's what it'll request, but it's not a PD chip specifically. So on the client board, there's no load switch. It's the buck itself has an enable, so you can turn the buck on and off, and the buck itself has a power good output, right, to let you know that it's good. There's no power good on these load switches. I could have used a different load switch. I was looking at some other TI chips, but I've got these. I mean, I've got them literally here. And so I'm going to just hook into the fault thing, right? Low if there's a problem, otherwise high if it's not. But high is always there, so I can't do, this won't tell me if it's good or bad. It'll tell me if it's bad rather than whether it's good. Does that make sense? I mean, each output PD being controlled by the device. That has nothing to do with the hub then. You're doing that at the port, Wagon Loads. That's irrelevant to anything, right? You'd have to put the PD support per port. Nothing to do with the hub, right? It's all going to be powered separately like I'm doing, but you'd have to do it. Like I've got here, resistors on per port, but you'd have to manage that yourself. This is not something I need, not something that's a different thing. Okay, I've done 3. Let me just keep going. So a few things to do. So why don't I just do this? Be easier. Oh God. I'd like to keep them the same if I can. Just because, make it pretty now. Yeah, so this is going to turn into an absolute overkill for a test. I just wanted to test the chip, make sure the chip works okay. That's all I was looking at doing. And this is turning into a crazy thing. But it could end up being a cool, useful, crazy thing. So I might as well do it, right? That's what I reckon. Okay, so I'm running out of space. Let me just move these out for now. Move these up. If you enable multiple ports, won't the 5 resistors end up in parallel? No, the resistors are in per port. They're at the port level. They're not connected to anything else. Each port's got their own unique. I got to update the labels on them. So like you see here, that's got USB 3 CCs, USB 4 CCs. Shouldn't the host USB port have a different setup on their CC resistors? The 5K one ground is for a device that uses power rather than provides it. I'm not providing power from the host. What do you mean? Oh, you're talking about for this? That'll just get ignored. No, that's the host is providing power to this. This is requesting that, and this is also, or this here, this is coming from a USB power supply, so that'll get. I still think we need these for the, like if a maybe I don't know, but again, I'm not using the I'm not doing any power at all through the hub chip. So the box will make 7-port device with JSON controlled outputs. Well, JSON's just a when you say JSON controlled, you mean whatever controlled. That's what this can do. And you're at 1 to 7, you have the CC resistor set up as a current using device, not providing one. Oh, I see what you're saying. Right. Well, they don't need any CCs on them at all, I guess. The device connecting to it has the CCs. Yeah, I wonder what will happen. Right. That's interesting. Well, I know what you're saying, Wagonlows, but the JSON bit's irrelevant. It could be a web interface, could be a XML, it could be whatever, right? But sure, turn on port. Well, you can't. JSON's not a transport layer. JSON's just a descriptive thing. How are you going to get the JSON to the port, right? To the device is what I'm saying. Yeah, that's interesting. So I don't need them. These are outgoing ports, so I don't need them. Is that what you're saying? Only the incoming ones need it. I think that's what you're saying. SAMD2660. So yeah, I should probably just get rid of those, shouldn't I? I will. 5. Oh my god, 5. Sorry, I can't. I'm looking at chat and I'm looking at here, and I'm yeah. 5. Okay, let me just extrapolate these, and then we'll go back to the Did I do all of them here? 4, 4, 4, 4, 4, 4, 4, 3, 2, 3, 3s, 2, 2, 2, 2s. Yeah, I did. Okay. The CC on the outgoing port should be used to sense what the downstream device is requesting. You should have something. Well, no, because I'm not negotiating the power. There's no request. I'm not letting the device decide what it wants, right? The devices have no. I know that's how it's supposed to be used, but the use case for this thing is not that. And there is no PD at all on this. It just taps into the power coming in. Yeah, okay. Let me just keep doing this. I've not said I've thought much of this through, because this is not where this project started. So, and it's not what the project was for. It's just what it's turning into at the moment. I'm going to leave the CCs just for the moment, and then I'm going to have to I don't know, look online about, like, I don't even know what a Raspberry Pi power supply, like a okay, like here's a Raspberry Pi 5 amp power supply, right? If I just plug that in and connect that to this thing, the thing's it's gonna want the negotiation of what the power is. No, it's not derailing. It's a very good point. It's a very good point. I don't know what I'm going to get out of this if I stick 5.1k resistors there. And by the way, the reason I'm doing this as a design layout rather than trying to integrate this into the client design is I can't show you the client design. I can't work on the client design on stream. And so and as I said, this is turning into something way bigger. Will only give you 5 volts, 5 milliamps if it's the 5.1k resistors. And if I don't put resistors on USB 5, missed. Thank you. Thanks, Joe. I think you need 10k pull-ups. That tells the sync device it can pull 3 amps. Well, I don't even know. I've never checked. So pull ups or down? So the CC1, CC2 need to be 10k pulled up. Where did you find that spec from, Julian? I've never even looked at any of that. Okay, so I'm going to mark all of these as do not place. I'm not going to delete them. They probably should be gone, but I'm going to mark them as exclude from, do not populate, exclude from position file, exclude from board, exclude from bill of materials, exclude from simulation. CC creates a resistor divider so the device connected knows. Yeah, I know what it does, but I'm asking where does the spec, where does it state 10k pull-ups for 3 amps? You need the pull-ups on the CC, the main one that provides power like a laptop or pulls the CC lines up to a voltage source. Hey, Johnny. Right, I understand, but I guess I'm trying to. So, is there a where did I put that web page? USB-C CC1 resistors. What's all those slashes? Pull-ups are a cruise signal system. We're not using power delivery. Yeah, I guess I want a table of what the resistors would be for what amperage. As I'm just wanting to look a standard Super Bruce posted something in Discord. Okay, so from Discord, so pull-up resistors on downstream facing port must be connected. Value resistor select advertises the current supply capability of the port to the device. That's the downstream. The upstream facing port must connect a valid pull-down resistor. What? How can it do a 20%, 10% to determine if it's detect power capability? What? No, I understand how it knows, but I'm trying to understand. I've never done an upstream or it's always anything I've ever worked on is a device that connects to something, not presents a USB for something to connect to, right? So I just need to get my head around what. So an upstream facing port. So upstream facing port is the ESP32S3, for instance, right? Oops. And the downstream facing port, the thing that it's going to be connected to, must be connected to both and maybe pulled up to that. Okay, so I need to do 10K pull-ups. Okay, so if I'm connected to 5 volts, I need 10K pull-ups. Catch you later, Amory. Thanks for joining. Okay, so this needs to be 10K pull-ups. No way. Get off. Oh, Up. Yeah, I've got, well, in this case, 5 amps I can supply through a 5-volt power supply, which is all I need, right? Like, again, not how the client device doesn't use USB-C for power delivery, power coming in. It uses like a power brick, a 20-volt, 19-volt power brick. So none of this is needed for the client. This is only something I need for this because I don't want to add all that circuitry. I just want to use a supply from Raspberry Pi, right? Okay, so that'll indicate. No. That's not what I want. That's not what I want. This. It's not 3 amp times 6. I'm not putting it on here. Okay, remember, stop. Each one of these is not an individual power supply being connected. I'm passing in the 5 volts, whatever it is, to here. There's no negotiation happening. The CC stuff gets ignored because I don't have something that negotiates and decides what the current thing is. At this point in time, this 5 volts is whatever the 5 volts is that's been negotiated. What do you want to send a link for? Right, that's why I just got rid of that. But this is saying I want 500 milliamps, isn't it? Can you post it in Discord? Are you on Discord, Joe? Okay, hang on, let me just change your settings. Okay, you can post it here now. Hey, Rob. How you doing? I'll deliver enough amps that you can draw 3 amps on each output port. No, not with this design. Maybe with a normal hub, not with this design. There is no negotiation happening per port. That's right. This here is just acting like a connector. It's just acting like wires. It's not saying here is a host or a power supply on one side and an ESP32 is connecting to it. This is just a USB-C connector instead of wires. That 5 volts here is not being asked for, negotiated, amps, not amps, doesn't matter. Okay? Pretend that this is just a 5 volts from a bench supply. Right, that was the link I had. I clicked on before. I just didn't get to that page in time because so everyone here is confusing what these USB-C ports are. They are just a connector. Yeah? It could be USB-A, it could be JST connectors, it could be screw terminals. It doesn't matter. It's just an opportunity to connect things together. The question is, how do I tell the power supply that I want as many amps as it can give me? That's the question. And I'm pretty sure that doesn't say, give me as many amps as I can get. I'm making a Chinese. No, I'm not making a USB-C hub. I'm not. That's the point. This is not a hub as in a product, as a hub that has to be on a spec. The client product has none of this. There's no USB connection at all in the entire product, right? But this is the easiest way. Like if I wanted to test this and stick 6 tiny S3s onto it, well, the only way I can do that is to plug in 6 of them in with a USB-C cable, right? So that's the only reason I've got USB-C ports here, apart from the connect to the host. Is the max 5-volt profile under USB PD? Higher currents probably use the same logic as you are. Hey, you're welcome, Rob. No worries. Might find it use. So the 5.1s just tell it to turn on 5 volts. Okay, so they stay like this then, and these do nothing. I don't have these connected. I'm pretty sure that's what I want. Because I'm not doing any negotiation. I'm just letting the 5 volts through whatever it is. These ports here are only for convenience, so I can stick... Not that I can find one in front of me. Ugh. So I can stick a tiny S3 in with a USB-C cable, right? That's the only reason I've got USB-C ports on here. So I think this is what I want. With no... Well, these just would have got ignored. Because again, no negotiation would have been taking place. It didn't matter what those resistor dividers did. The 5 volts is the 5 volts. What if the device you plug into the port has CC resistors on it? It'll get ignored. It'll get ignored because there's no negotiation stage. There's nothing, there's no electronics or logic that does anything. It's ignored. I would put the CC resistors on the ports anyway, even if the current device isn't going to use it. For the upstream. But if I was going to put them on here, I'd need to put pulled up resistors. And I don't want to pull up at 3 amps because that would be 3 amps per port, which is, well, I think what Sam D mentioned. Where was that thing? 12 USB power, 5 milliamps for USB 2, 900 for USB 3. So I'd have to put either 56K pull-ups or 22K pull-ups. But none of my devices are going to pull this much power current anyway. The part number for which device? There is no device. If you meant the hub, this has nothing to do with the hub. The power is separate to the hub. I'm not using the hub chip for power. Right, but it's USB compliant. If that's the case, well, I might as well then just... I need to do the 56K pull-ups. Because it's not safe to do anything higher if a power supply can't deliver that. Okay, so I'll do the 56K. Oh, what a pain. Gotta redo all of these. Most hubs, even powered ones, are massively over. Yeah. No, this has nothing to do with the CH339. Power is totally independent, on purpose, by design. I'm not going to be able to get these in. Oh, I can just do this. I'm going to be lazy. Just going to do that. It looks down, but it's a pull up. Pull up to the power. Okay. There was an interesting discussion, though. I've never really considered what the CC resistors would be on the ports presenting. Hadn't even occurred to me. So, thank you. Whoever started that conversation, it might have been Samdy, I don't know, but thank you all of you that contributed to that, because that would have been that could have been a problem. Maybe yes, maybe no. Hello? Why is it not letting me click on the... KiCad's doing some weird things. This is KiCad 10.1. God, they had some pretty bad crash bugs in KiCad 10.0. Let me tell you. But this is better, but it's still doing some weird things sometimes where maybe it's just a Mac thing, but cursor placement is just screwed. Or it doesn't place things in the right spot. Device role sync off connect 5 resistor from CC to ground. Tells the host source that a device is connected, triggering 5-volt supply. That's why I mentioned. Yeah, to place support without a resistor. Yeah, I know. Well, not all of them do, but some of them do. 56K is a host role. Correct, and these are host ports. These are the ports that a device is going to connect to. The CC pins connecting to the CH chip is still a separate topic, Wagon Loads. If you want to be doing PD controlled power, you'll need to do that separately with a separate PD chip. Kind of like what I'm doing here, but where the power comes through a PD negotiated chip. Yes, I know that. That's what's on that. That's why I'm doing 56K. I'm letting it advertise just standard 500 milliamp for USB 2. That's all I need in this particular case. Wow. Okay, so now I need to do this. Too soon. I don't even have a let me just switch these. Hang on. Okay, 1 second. I want to flip these around. 1, 2, 3, 4, 5, 6, 7. Okay, so USB 2. Wait, 2, 2, 3, 3. That should be 4. 4, 4. It should be 5. So, again, I'm using an I/O expander for this, which again is similar to what I do with a client board. Hi, Amanda. As I said, the CH339 chip does not do PD negotiated power delivery. You need a separate chip for that. They have separate chips for that. And they discuss that in their documentation. Wagon Loads, you can't do PD on this hub port. You can set common resistor values for your ports if you're using power through that chip, which I'm not. but it's not a PD. It's not a full PD implementation, I don't believe. Check the data sheet. I don't know. It's something that isn't. It's not something that I'm. I need say 6. So 1. Okay. So there's obviously not enough I/O on the S3. So they're not using. So the current hub, client hub, is not using an ESP32 as the internal brains. It's using a MSP430, 100-pin MSP430. So, but still, even that doesn't have enough I/O for all the things, and so there's I/O expanders on there anyway. What criteria makes you turn on and off the downstream port power? Device detection. Right. So I haven't got to that bit yet. I'll explain that in a moment. Let me just put this on. So this is fine for one port, one hub chip, 7 ports. But I'd need 2 of these, one for each hub chip for the 12 ports. But this is fine just for now. Once I label these, and then we'll get to the sense stuff. 6. And 7. Right. I'll finish it. Okay, so the way it works on the client board is that, again, they're not USB-C ports, right? It's a special, it's a custom interface, right? A device gets plugged in to a specialized magnetic connector system, and that connection triggers a sense pin, right? Like an I/O. And the microcontroller gets the message that a device has been plugged in, right? Because the device is battery powered, always battery powered, like always on. It's in sleep mode, always, or it's awake running. And so that connection wakes up that I/O, triggers an interrupt, and so then the MSP430 knows that port has been activated, and it turns the power on for that port. Now, in my case, I can't do that because I've only got what's on a USB-C connector, right? So I want to be able to plug the USB-C. So there's a couple of ways I could do this. I could use the D+, D- that get pulled high automatically when a device is connected to start with. I could tap into that, but my concern of tapping into that, if for USB 1.1, I'd probably tap into it. But for USB 2, high speed, I think that tapping into that is going to cause interference on the USB lines, right? Over the air pin. What? Okay. Hey, Matt, how you doing? Oh, Superhouse? What? Hey, John, how you doing? Welcome to USB Layout Fun. Yeah. So what I'm going to do is so this is interesting. It's not going to work now. What I was going to do so I've got these sense pins, right? So sense 1, 2, 3, 4, and then 5, 6, 7, 8. Well, actually, they need to be used now. All the way up to 12, but I need up to 7. But I don't need 1. Because 1 is taken from the ESP32. Just hold on 1 second. I don't know how this is going to actually work. 2, 3, 4. So I was going to tap into the I was going to do a divider from the power, but that's not going to work. I don't know how I'm going to do this now, actually. To be honest with you, Julian, I don't know how I'm going to do this now on this design, because this is something that I don't have enough pins on the USB. Oh my God, that's 6. And that's 7. What I want to do is detect a device is connected and then turn the power on, but there's no power to detect it. No, wagon loads. For what you want to do, maybe. No, not for what I need to do. Right. So, as I said, with the client product, the device is always powered. There's when you connect it, there is 3.3 volts always going through a pin on the connector that goes through just a current limiting resistor that automatically, well, multiplex isn't going to help me, that automatically says there's something on that port, therefore power it up. But there's nothing I can use, nothing here I can use, because a device that doesn't have, a device going into the USB port that doesn't have power has no way of triggering anything to say something is there. And sure, if it was a battery powered device that had power already, I could do that. Because technically, if there was power on the board, then there's data, the data lines would trigger. But if the board's not powered, there's no data. Well, data's not connected anyway. Data might be connected, but there's no power on the board, so data doesn't do anything. You could look for the 5K1 pull downs. Use the CC pins to connect them to power that is always on. Interesting. Okay. Hello, Liberty Wool. Welcome. The external product is powered by. Correct. I can't. The only way I can simulate, the only way I can make this work like the client board is to not do anything I'm doing here and implement this onto the client board, right? That has all of the other infrastructure required for this to work, including the custom connectors and everything else, which means I can't plug a tiny S3 into it. I need to plug only their devices into it to make it work. That doesn't allow me to experiment with the chip. I want to be able to experiment with the chip and stuff with it, but then I'm limited to whatever I've got on USB-C port. But the Liberty Wool suggested use the CCs, and that's actually not a bad idea. Check connection between ground pins or VBus pins on incoming device. Yeah, that's not going to work. Sync device, the 5K pull downs. Yeah, if I don't have these, if I have these go straight to the main source, so they're always pulled up. And then when a device is connected, wait, will they pull down? If there's no power to the device, they won't pull. They will. Because ground is connected and the divider would be working. Yeah. Yeah, okay. I think that could be. Oh, hang on. But then okay, no. Oops. Can you imagine having to lay this board out? It's going to be a disaster. That's just for, isn't USB like 5 volts, all the things, but you are feeding? What do you mean? I asked. Yeah, so it'll have to go through a divider. But then I'm messing with the CC pin. So for instance, I would need so USB 1 CC. Let's say I use that one, right? USB 1 CC would need to go through. So USB sense would have to connect to. Well, actually, no. Hang on. Oh, yeah, it will. It would have to go through a divider to bring it down like this. But that's going to affect. That's going to drop. So if it's 5 volts, it's going to drop it to 3.3 or to 0, but that's going to affect the CC value. Well, I can't look for a certain number of volts. Like it's gonna be an interrupt. So it's going to be a high or a low, Julian. So hang on, back to Discord. So that had this is. So you're saying I should, if I pull them to 3.3 volts instead of 5 volts with a 36K, then my output for them is going to be 3.3 volts. Is that how that works? CC won't have high or low 8 channel. Yeah, I that won't help. I need an interrupt on a particular thing. It's got to be an interrupt, not polling, whatever. Well, they might be, but I can't use an ADC to read them. I need it to fire an interrupt. Something gets inserted, the voltage drops, fires an interrupt. On that I/O, lets me know which one has woken up. I turn the power on that device, right? Oh, no, not simple. Can't do that, wagon loads. This is all independent of the CH chip, and there are no sense pins on the CH chip. You'll keep muddying things. Can you use a comparator? I could, but 5K pull down act as digital low. The digital low is fine. It's the digital high is not. It can't be above 3.3 volts. Right. It'll trigger a low. I can't leave it at 5 volts high, is what I'm saying. But am I correct in that if I use a 36K instead of a 56K? Hang on. So if this was a 36K, and they were both connected to 3.3 volts. If you use 3.3 with nothing connected on the 36K pull-up, it will float. sure what you mean. But if I did this and I tapped into that, it'll be a 3.3 value or a it'll be high or low at 3.3 volts, right? Wouldn't it? And then I don't need a divider. If that's what I understand from that data sheet or from that table. I can use internal pull-ups. We also have to deal with only one of the CCs being like, depending on the orientation. Yeah, that's true. Oh my god. Okay. Effectively, with nothing connected, you just put in 3.3 input through the resistor, not a divider, until something's connected, which drags it down. Right, but I don't know which pin. So only one of the CCs gets used depending on the orientation of the port. So, and I don't have enough. I mean, the only other thing I could do, you need 2 sense lines per port. So I would need another I/O expander, and each one of these CCs would have to go into here, and then I'd fire an interrupt, and then I'd have to scan for which changed. Yeah, it is weird seeing them like that. So I don't have enough room for 2 cents per port because I need to be able to support 12 here. But if I did it through another I/O expander, just hear me out. this is CC interrupt. Right, but this means that I get an interrupt fired and then I have to poll. It's not the same. Sure, it'll still be quick. It's not quite the same. But I could do this. I could just go. I'll close them up in a second. Right, and then I could CC1, CC2, that'll be 3. And so on, right? Why not just do this? 3, 4. I have to change them all to 3.3 volts. 5. Again, this is already. God.
Intermit Tech says, I wonder what is cheaper, another expander or a dual input Y chip and then connect directly.
Wait, I wonder what is cheaper. A dual input Y chip. Dual input Y chip. What is a dual input Y chip? Firstly, I've got thousands of these I/O expanders. Secondly, they're cheap. But because I need one per. What's a dual input Y chip? You mean like a splitter? Like an right. So an AND or so. So I've got all chips on. Hang on. It's a lot of circuitry for an ore chip. Well, it's a hang on, I'll show you. So on my Feather S3 and my Pro S3, I've got I use it to turn LDO 2 off when chip goes into deep sleep. Right, so here I've got shutdown here. Oh, that's a bit screwy. So I could effectively oh my god, what just happened? Copy that. Paste it. There we go. So that'll have to be powered. That'll be 3.3 volts. Actually, I wonder what. Let me check the input voltage range. That'll be interesting. Why is this not letting me? Whoa. Look at that. Ah. That's weird. You pull up to 313, then connect each CC line via a 100k resistor to the sense pins. Hey, Monster Mark. Yeah, I don't think it'll do the bridge because if the 5 volts coming in, it'll be 5 volts going out. I need to work out what's going on here. Look at these, they're not in the right spot. That is bizarre. Not my thing. Hate when they left justify the labels. Okay, save. Okay, so this would be. I'm just. I'm not sure I want to do this, but I'm just thinking about. And that'll be sense. What do I call it? USB sense 2. So if I leave them at 5 volts, I could put that through a divider. And if I left them at 3.3 volts, then that would be 3.3 volts. CC on 56k, or if you want to be closer to spec, VCC2, same value. MCU pin. Yeah, I don't have 2 spare MCU pins for each CC for each USB, Rob. So my first problem is I have to have a way of checking either CC, because depending on the orientation of the USB, and only end up with one result either way. That's the first issue. That's what this OR could technically do. How do I only need 1 sense pin? Yeah, I could put us here if I was leaving them at 5 volts. I don't understand what you've drawn the CC side, CC1 to 3.3, CC2 same to 3.3. I don't, okay. CC1 goes to 100K, which then goes to MCU CC pin. CC2 goes to 100K, then goes to the same pin. I don't understand. Oh, it's trying to be difficult, Rob. I don't understand. You'll need biasing on those and inputs, though. No, because they're biased here. Sorry, so they're already pulled up here. Yeah, please, on a picture, Rob. I can't. I can't get my head around that. But if I can pull those to 3.3, I don't need a divider. It's 2 less components. But I do need a cap on the power. And that's a SOT. What is it? Oh, I can't remember what it is. 366, 566, 556. Well, 2 diodes is kind of doing what this is doing. Kind of. Are you going to propagate that 5? Propagate? What do you mean by propagate? What are expensive? These? If you meant these, yeah. US. I didn't make these 56. It should be 56. Yeah, these are 56 or 30, 36, whatever they are. Also, not 5-volt compliant, but there are lots of you should be able to get. Sure. So at the time when I was trying to find these, something like this, in a small package that was reliable, I mean, this is years ago. When did my Feather S2 come out? Jesus. Yeah, it was very hard to find these at the time. It was during the silicon shortage. I don't want to come up with a complex diode solution for this, though. So 6 of these would remove that and polling and whatever. this would remove 7 sense pins. I just need one interrupt. So I'd free up a lot of I/O on the microcontroller by doing this. This means I need 6 of those. So I need one of these, one I/O expander. I need, right? And that would free up all the I/O. This I'd need 6 of, and it won't free up the I/O. But that won't need polling. So, I mean, I'd find a nice one DRAM package or something. Oh, maybe now, but back then, during the silicon shortage, during COVID and the silicon shortage period, I couldn't find anything. I ended up, I couldn't find anything on LCSC. But 5-volt tolerance. What's the need to go 5-volt tolerant when I can use 36K on 3.3 volt? Any idea? And I've got these. I've got reels of them. Yeah, I don't need a new part, Wagon Loads. I've got parts. I've got reels of these in stock. I've got 1,500 or so of these in stock. I'm trying to use what I've got, especially when I might only ever build one. There will never be 5-volt on those pins. On which pins? Both these options are valid. 6 of these. If they're pulled up to 3.3 volts, there'll never be 5 volts on them, no. If they're pulled up to 5 volts, there will be. So I just have to decide if I want to go that route or this route. Or find a 24-port I/O, again, 24-port I/O expander would... The problem is with two of these, I need 2 of those and 2 of those. But if I had a 24-port expander, 2 of these would just need 1 of those, and 1 24-port here and 1 24-port here. Least chip solution isn't the thing. Least chips requiring sourcing more parts, more feeder positions, more whatever is not... That's not how my head works, Wagon Loads. Well, when I'm designing, I'm also looking at part availability, what I have in stock, manufacturability, all those type of things. Point. Yeah, I think isn't a low under... Oh, that's a good... I'm sure I got a good answer to that one if I can... is P32 S3 IO low max voltage. If the IO low voltage threshold, maximum input voltage that is still registered as logical low is typically 0.25 times VDD. So 0.8 volts at 3.3. So yeah, that should be good. 0.4 should trigger a low, no problem. So Good question. Let me ask the same thing. IO expander low state max voltage. VCC 2.3. VCC 2.3. Let's if it is an input, the maximum voltage it will read as a logic low is 0.3 times VCC. So it's the same. 0.3 times 3.3. Well, it says 0.9. I think it'll be fine. Because on one of the CC pins, the one not used for communication is used to power the cable's internal electronics. You mark out with 5 volt, which is known as a VCon. I don't know what that is. To power the cable's internal electronics. Well, I don't have any. I'm not supporting any internal electronics in cables. These are not intelligent ports. They're just USB ports. So I still don't know which way to go. I mean, it's cheaper to place one of these than it is to place even one of these, I think, let alone 6 of them. Geez. I told you this is getting out of control. I still need to do this. It's a fault and whatever. So I need a fault enable needs to be pulled up, and then fault enable. Oh, that's not good. Come on. No, I just want that and that. 2, 3, 4. I fit these here. The logic gate needs an AND gate as well, not OR, which would be a new IC. Why? No, I need an OR. I need, this is low. Oh, I see what you're saying. That the one that's pulled up will still, right, I need them both to be low. So I need an AND. You're right. You're right. So that, whoops. So this option is gone because the OR, I could, I'd need an invert OR, because the one that's not being used will always be pulled high. Only one will get pulled low, which means one will always be high, which means the OR will always be true. Because if one's low, one's high, that's OR. The other way, that's OR. So AND, well, I needed an AND or an inverted AND or an XOR. But yeah, no, because if one changes, No, the result, if both are 1, it's true. If one is 1 and 1 is not, is true, and that is true. Only if both of them were low would it be false with an OR. And only 1 can be low. No, it doesn't depend on how they're utilized on the device. It's flipped around. When you plug the USB in one way, only one of the CC pins is used, and when you plug it the other way, the other CC pin's used. But only one is low. They're not both low. That's right. So, oh, hang on. What? No. No, that's not what it is. Sorry, you're wrong. L plus L equals L. L plus H equals high. H plus L equals high. H plus H equals high. That table is wrong. Your table is wrong, Intimate Tech. I'm pretty sure. Hang on. It's not. Oh, hound, is this an inverted? It's not inverted. What datasheet link are you looking at? Quindor? Oh, low is low. Oh, it's an AND gate, not an OR gate. Oh my god. Sorry. It's an. This whole time I've been saying that it's an OR gate. It's not. It's an AND gate. Okay, I need a. Firstly, I've got this much coffee left and it's ice cold. Secondly, I need a coffee. Oh. Stop, everyone. I've been saying it's an OR gate. It's an AND gate, not an OR gate. It's an AND gate. I'm using an AND gate, not an OR gate. It's not an OR gate. So, an AND gate. So, Quindor is correct. The logic for an AND gate is correct, and it will work. If it was an OR gate, it would not work. So, this will be true if nothing is connected. And if something is connected, either way, this will be false because one of them will be low. So, Quindor, I apologize. This chip is correct. You were correct. I don't know why I called it and thought it was an OR gate. It's an AND gate. Oh my god, my itchy face. For those that came late, I'm not deliberately growing a beard, but oh my god, this is so itchy. I'm at the itchy stage. Not happy. Oh, yeah. Digital logic classes back at at Chisholm at the time, at Monash. So, this will work. It's an AND gate. Yeah. Yep. I losing my mind. I think I might actually do it. just for shits and giggles. I'm going to do it. I'm going to do this. I keep hearing someone outside, but it's not for me. What are we doing? Someone in the chat, please tell me. Oh, what are we doing? We are making a mess of the USB standard. That's what we're doing. Okay.
Alan Madsen says use a beard oil.
Use a beard oil. What? So then I'm going to have an oily face. Does that actually help? Alan? Okay. I hadn't even finished. Oh my god. Hadn't finished doing
Alan
the.
Madsen says OHH yes it does.
Okay. I'll have a look at. I don't even want to grow a beard, I don't think. You know, some people just look good in a beard. Not me. I don't think. And Orly, my daughter, was horrified to hear that I was thinking of doing a beard. 36k. Do you understand that all of this stuff we're talking about and all this stuff I'm doing right now is all pointless for the purposes of this for my client? Okay? Totally pointless. And none of it is required for me to test if the chip will do what I need it to do reliably as a replacement for the other one. So it's there's 6k.
Alan Madsen says yes. When I see your face with a beard, I can understand her law.
Thank you very much. Love you too. Discord PM for you. Discord PM. Discord. Hello, Mr. Discord. Okay. PM.
Alan Madsen says pure love lol.
So, Rob, so can I show this or not? Can I show the picture? New phone, fancy. Okay, so this is what Rob sent. So you're just using. Okay, the problem here is you're relying on the whatever's got the highest voltage through a divider, but that divider is also affecting the CC pin. You're basically putting a that's a divider on there, or are you relying on this being an input high impedance, which I can't really do? It's got to be an input that's either pulled low or high, and we want this input to be pulled high, but that won't give us a high. I'm growing sandpaper. It feels like sandpaper right now. Let me just say, I'm just going to switch back to just full screen for a moment. Full C on. The last time I grew a beard, there was none of these whites and blondes and greys. So I'm curious to see what it looks like. It was dark. Anyway, it'll get pulled low. Anyway, I'm going back to here. So what'll get pulled low? That's a divider on the CC pin. And then when I connect 5.1K, what this is going to be presenting is not 33K pulled up, 36K pulled up to 3.3 volts. Because you've got a divider on here. Lamagura look like Father Christmas these days. Barely dark hair in sight. Yeah.
Alan Madsen says the white grey has something to do with age :
No, it doesn't. I'm aging backwards. Would always be through it because in the middle of the divider with that on both sides. Yeah, I'm not sure I'm understanding how this would work. I understand how it would work if the CC pin presenting the value didn't care, but this is going to affect the CC pin and the 5K1 on the other side, which forms a divider. This and the 5K1 form a divider. It's going to be I don't understand how that would work. I'm not saying it won't. I don't understand. I can't do that in my head. And yeah. But I'm not sure I trust that. I mean, I could try it. I wouldn't want to risk a board on it though. I want to I think I want to move these over. That is doing my head in. Just bear with me. Sorry, I hate this. Hate it. Low enough. I'm being finicky. I know. What can I tell you? I shouldn't be spending any time doing this. I could also, let's just do, does that look terrible or what? Supposed to say, or what? It's still too big. Let's do this. Yeah. Ugly. Ugh. That's shocking. Could throw the design a little too spice. What? No. Get past the itchy phase. It saves so much time shaving once you have the beard. Yeah, but my family won't let me in the house. Some resistors and a spare MCU or two lying around to give it a try. Yeah. Just one or two lying around. I'm sure I do. Oh my God. So I'm doing this and I'm doing this. Okay, 1, 2, 3, 4, 5, 6. Is that not shocking? Yep, that is shocking. What key did I just hit then? Okay. So that'd be USB 3. I'm sure this is solved by someone already, right? I bet you there's someone's already made a design that does all of this thing. I'm going to be making the most expensive over-the-top USB hub. No. Back. Why don't you use another sheet for the repeating pattern? I hate using multi-sheets, at least when I'm designing anyway, and jumping between them and stuff. And for repeating pattern stuff, I hate the way KiCad deals with repeating things. It did it again. What key did I hit? Anyway, okay, so that gives me all my sense stuff. And then that would be 8 and 9. 10 would be there. So this just frees up another. I don't need that. So I've got 1, 2, 3 spare I/O at the moment. 3, 4, 5. 5 spare I/O. Some of the things that are on here are client-facing stuff. We don't need to worry about them right now. Is there a chip with 6 AND gates in one? I'm sure there is, but I don't have one. No, we don't want that. Oh, 6 AND gates, unique AND gates. Yeah, I'm sure there is. Yep, lots of them. A good engineer is great at appropriating others. Maybe. Okay, so I don't need that. Okay, so is this everything? I've got power enable. I can turn each one of them on. Maybe. And I've got the fault check, which may or may not be useful. Fault's already pulled up. Oh my god. I'm already pulling up the fault here. Someone shoot me. Shoot me. Fuck. Okay, so I've got fault in, which may or may not be useful. There'll be inputs, power enable, outputs. I can sense them all through these, I hope. And I've got my 5 volts, my main power, and my host, which goes through the hub, my 3.3 volt regulator, just one. I could do more, but just one. ESP32 connected to USB 1. I think that's everything, is it? Like, am I ready to bring this into PCB view and have a heart attack of what needs to be done? I think I might. I'm going to fix these. because they're pissing me off. They need a cut tool. I can just cut a wire. Six 67755443322. Okay, I am going to hit the. Ready for this? Ah! I'm gonna want to lay this out. Cannot footprint further through slot 553. Wait. Okay. Oh, you know what? I can't bring this in yet at all because I've not set any of the freaking footprints for any of the resistors and caps. So I spent a lot of time in the in this now. Pretty cool. Okay, so oh my god, what just happened? What a 12 picofarad. C7, C8. 12 picofarad? Oh my god. Okay, sorry. It's the crystal that I'm not placing. So, yeah. Okay, so they are caps. They are, that's 0603. Pretty sure that's. Yep. So just an easy way for setting footprints and stuff. Just do it through here. 0.1. They are, yes, nice big chunky ones. Oh, Johnny, did you see I'm using pink and purple LEDs? Very exciting. Pink and purple for power. Actually, we're overcomplicating since only CC one also gets connected. The other is floating. Just connected CC together. No, you can't connect them together. That's what Raspberry Pi did, wasn't it? When they first released their Pi with USB-C and had to recall millions of dollars worth of things. Okay, this is resistor. Resistor. Okay. Yep. Okay. That is apply. So how quick it is to do footprints now. So now I should be able to bring this in. Whoop. Total warnings, 0. Errors, 0. Update. Oh, Jesus. Ah! USB hub with microcontroller and I/O expander. It's a USB hub six port USB hub. Was a 7-port hub, but I'm using one of them for the S3. There's a 6-port hub that has a micro on it for controlling, doing stuff. Yes, but it's a proof of concept of this chip more than anything else. I mean, the sync device connects only one to ground, leaving the other not connected. Yeah, I'm gonna stick with this for the moment, Rob. Okay. Turn off all this rubbish. You know what? I'm just going to all edit text and graphics properties, select it only, and make them not visible. Apply. There we go. Much quicker. Shim sync devices, cables work expected. Yeah, it'd be pretty not standard doing that. This will be a module with an external antenna, not this. I don't think. I don't have an expressives library. Oh, there we go. No, they have the one U. Okay. Change. Good. I don't need that. I don't know why there's a keyboard zone there. Anyway. Okay. Wow. How long have I been going for? 2.5 hours. Wow. I thought I'd be fast asleep by now. I don't even know where to start with this, to be honest with you. I'll start grouping stuff together. This is not going to happen today. I'm just letting you know now. This one is my host port. 4, 3, 2, 7, 6. 5. Okay. Okay, that's my power. That goes down here. That goes over here somewhere. Move them. They're the load switches. They're the and gates. Wow. What's the expander over here? Now, obviously, I need to work out how this board's going to work, because I'll have the opportunity of doing some, easier routing on this. So I need to do length matched 90 ohm differential pairs for the hub. And the easiest thing to do would be to have the ports go around it. Not so easy on the client board. Works very differently. But selecting the schematic, a block of components. Selection is done. Yeah, I know it is. Yeah, that's a good point. That's a good point. I should have done that. You're right. I was okay. How the problem is it does it like this, right? So it doesn't necessarily group them together. But I guess it's a starting point. Um, hub one. Hub one, port one, port two. I wish there was a way that you could set the packing. Maybe there is. Anyone know if there's a way that you can tell KiCad how to group stuff together when it puts it into the board? That would be useful. Plug into register components based on the schematic. There is? Okay. Any idea what it's called off the top of your head? I mean, it doesn't matter for the moment, but okay, all good. Yeah, no worries. Thanks. I can have a look online. There, 6 USB ports. Helps a little. Hub. Yep. Expander. Okay, and these are all USB. Oh, okay. Catch you later, Foo. Oh no, it's Alan's going. Okay, good night, Alan. Mother to hang up her new TV tomorrow. Cool. Enjoy. Don't drop it on your foot. Okay. Wow. Not challenging at all. Okay, LED. Design's done. Okay. I'm doing this and then I'm going to stop. I have a whole bunch of I'm not going to tell you what I've got to do. Lots of wires, trimming, tinning, and soldering onto flex foils. Flex PCBs. Yep. So I'm going to just kind of rough this power part, the upstream. I don't even need the diode. Don't need the diode. Pretty sure. So not the diode. Sorry, I meant here, this backfeed diode. Pretty sure do not need that. I'm not going to get any type of rubbish coming through. Oh, that's going to be for 3 volt, 3.3 volt power. Okay, so upstream port, power port. Oh my god, turn snapping off. Okay, just put a TPS, a 73201 LDO on a perf board. Datasheet showed some values for the feedback, but it is off a bit. I want 2 volt output from a 3.7 battery. Okay, TPS 73201. Not sure what that LDO that is. Okay, I'm going to stop. That's about as much as I'm going to do. I need to I'll chip away at this. It's going to be crazy. Chip away, chip away. Chip away. I need to see some acrylic. I'm just throwing this out there just now at the end. Need to see some acrylic, large piece of acrylic. Can't fit it in my mill. And so I need to not cut it. I need to reduce some of its height, but not cut all the way through it, right? So laser's hard. You can do that with a laser, but it's very time consuming, and it's anyway, results aren't necessarily great, but I did some experimentation yesterday, and I actually managed to, on a test piece, on my 5th attempt, got it to, so here's a bit of acrylic, that's the front and the back, and that white is just because that's how it looks after it's been lasered. You can't really do anything about it. But if you can see, it's actually, it's like, see that? It's not quite the height I need. That's 0.8 millimeters, believe it or not. And I need it to be 1. No, that's, sorry, that's 1.1, and I need it to be 1.7. So I tried doing it with a laser. It's not great. And then you get that weird white bit, which has actually got a little bit of thickness, about a 0.1 millimeter from the side. You can see it, right? So it's, I was hoping that I didn't have to buy a large CNC, like a tabletop router, but I need to be able to cut 460 wide, like a 460 long sheet. And I thought I might be able to get it done with the laser, but not really. It was an interesting challenge, but it wrecks the acrylic too much. It's fine here, like looking through, but you're always gonna, I mean, the white stuff, I could maybe try to sand it off, but it's just going to also wreck it. Anyway, that was lots of a stinky lasering yesterday, which, yeah, fun experiment. Upcoming project to tell you about. Okay, I'm going to go. Thanks for everyone's help on the design. And it's a nice LDO. Just got some samples from TI. I want to know what it is. Hang on. When you say a nice LDO, define, no, it's only 250 milliamp. Too low. Would acrylic glue fill the laser frosting? Acrylic glue? What do I mean? And what do you mean fill it? I don't want to fill it. What? Glue? I'm trying to cut acrylic away, not cut through it. But yeah, I need. Do they make larger milliamp capacity ones? You got the Q1. No, I'm not joining acrylic. No. No, I'm cutting. I need to mill it. Milling it will be fine. I just don't have a big enough mill. I don't know what the Q1 variant is, but well, I'm always looking to see if there's anything that can replace the LDOs I use from on semi, but I've yet to find anything. Oops, it's not what I. No, that's right. 1 amp low noise. Yep, yep. Um, yeah, it's pretty cool. I bet you they're not cheap. Let's see if they're at LCSC. Probably not. Mauser. Nope. DigiKey. They're brand new, are they? Oh, God, DigiKey. Every time. Okay, I guess not. Let's go into the order now one. Well, 42 cents. 1,000. That's not bad. $2.75 to 6 volt, 6 amp step down converter. Wettable flanks package. Wettable flanks. Gonna love that. Stackable synchronous buck converters. Tell you, makes some really nice parts, I gotta say, but holy moly, these fancy footprints they're doing are an absolute pain in the backside. And all of these packages that require external inductors, no go. Look at these footprints. They are manufacturing nightmares. Really, really nightmares when it comes to manufacturability. Anyway, okay, I'm going to stop. Gonna go get a coffee, maybe take a snooze, and then I have about a 90, it's 90 times 4. 360 wires to solder. Woohoo! Okay, catch you everyone. Thanks for all your help on the design, and I will, next week, hopefully I'll have a routed PCB. If not, I'll finish it on the stream next week. We'll see how we go. Or maybe my other board will be in and I can assemble it. Yeah. Okay. Catch you everyone. Take care.